Hi, you're watching part 2 of building real-world mobile apps using the Telerik platform. In part 1, we looked at creating a mobile to-do list example app in the App Builder browser client using Kendo UI Mobile. The goal for part 2 is to integrate our new app with Telerik Backend Services. So while we're going to focus on using the storage features of our backend services in this video, it's good to know that there are a ton of other features available beyond that. Things like user management, SMS, email, and push notifications, social authentication services, usage metrics, and more. Let's start off with a quick review of what our app looked like when we left off in part 1. So let's open up our App Builder project and run this in our simulator. And we can see our work category to-do items. Now remember, this is based on in-memory data sources that we created in part 1, but we can still interact with it and remove the to-dos and so on. We can switch categories. We can add new to-dos. Okay, you get the idea. So I mentioned that these are in-memory data sources. So let's open our categories data source and see what I mean by that. So here's a Kendo UI data source instance, and in this case, it's just using this array of category data that we've hard-coded. Now if we open up the to-dos data source, we'll see that it too is currently using hard-coded in-memory data. Now before we can convert these to data sources that talk to Telerik Backend Services, we need to actually create a Backend Services project for this app. If we go back to our workspace, you can see that we have the option to do that here. So let's click Create Backend Services Project. So we have the option to start from scratch or start from a sample. We'll start from scratch. And next we just need to give our project a name and description. And then click Create Project. Okay, now we're on the dashboard for our newly created Backend Services project. Now this dashboard shows you metrics related to the project, and of course ours are currently blank since this project is brand new, but let's scroll down so you can get an idea of what's here. We have metrics for database and file storage utilization, bandwidth usage, push notifications and email counts, as well as HTTP requests. On the left-hand side, you'll see this list of icons, which we can expand to show the label. This is our nav menu for a Backend Services project. Overview is where we are. API keys loads a page containing any key information that your client app will need to connect to this instance of Backend Services. Types, which we'll use in a moment, is where you go to create new content types for data storage. You can also manage file uploads and storage, users, user roles, push notifications, and more. The first thing we're going to do is create content types for our app. So a content type defines a storage bucket for a particular kind of data, and we use a schema to define what that data looks like. So in the case of our to-do app, we have two content types, categories and to-dos. Let's create our categories content type first. Here we just type in the name, categories, and if we scroll down, we can see the fields that Telerik Backend Services adds automatically to any content type. In our case, we just need to add two additional fields. First, we'll add is default. Now this dropdown shows us the available data types for a field, things like text, number, date time, yes, no for Boolean, file, geopoint for geolocation data, object, relation, and array. So our isDefault field is exactly what it sounds like. It's a Boolean, so we'll pick yes, no. And next we'll add the name field, and it's just text. Now we can scroll down and click Save on our content type. So it's taken us to an items view screen for this content type now, which is currently empty, of course. Now the nice thing is, the Telerik Backend Services portal lets us manage our content types right here. So we can click Add an Item, and we can go ahead and create our default category, the work category. Now let's go ahead and add the personal and other categories as well to make it match that in-memory data source we had in our app from part 1. So we can click on one of the items listed here in our content type to see more details about it on the right. We could also edit it here if we needed to. And as we select other items, we'll see the details on the right change to reflect the selected item, just like you'd expect it to. Let's go ahead and create our to-dos content type next. We need to add a title field, which is text. And next we'll add our category field, but let's make things interesting this time and set it as a relation, and we'll define a relationship to the category's content type. This will store the category item's ID in the category field on the to-dos content type, effectively making it a foreign key to the category item. This is actually a bit more than what we were doing with the in-memory data sources in our app, so we'll have some changes to make in our app as well to support this. So let's go ahead and save that. Now I want to add a to-do item, but let's go grab the ID of our work category first. I'll copy this ID and jump back over to to-dos content type. Now we'll add an item. We'll call it Integrate Backend Services. Let's paste in the ID we just copied. So now if we view this item's detail, we'll see that the category ID is clickable. Clicking on it takes us to the category it links to. Now that we have our content types created, we're ready to start tweaking our app to talk to Telerik Backend Services. First thing we need to do is download the JavaScript client library for it. If we click this icon at the top right, we'll see a menu that has an option for downloads. Then we can scroll down to our SDKs and pick Backend Services. So in addition to an HTTP API that you could access from any platform that can communicate over HTTP, you can see that we also have client libraries for .NET, JavaScript, which is the hybrid and web option you see here, Windows Phone, iOS, and Android. So we'll pick the JavaScript download and select Backend as the project we want. And now we'll download the SDK. Let's extract the zip file we just downloaded and see what's inside it. We have both the unminified and the minified source of the Telerik Backend Services client library, which is called EverLive.js, and all of its dependencies. So let's grab all the minified source and put it in an archive so we can upload it to our App Builder project. Now let's jump over to our App Builder project and upload these files. We'll create a folder called EverLive under our libs folder to match the client SDK file name, and then we'll upload our dependencies to it. Okay, we'll get rid of this Mac OS X artifact that made it into our archive, and we can see all the JavaScript files that we uploaded. You'll notice we have an everlive.min.js and an everlive.all.min.js. Now for today, I plan to use the everlive.all.min.js, but I included the other files for two reasons. First, I wanted you to see what Everlive's dependencies were. Uses JSTZ, which is JavaScript time zone detect, request, RSVP, and underscore. Now the second reason I included these dependencies is that later on in this series, I plan to go over better ways to structure and load these types of dependencies as AMD modules. For today though, the everlive.all.min.js file has all the dependencies combined in it, and that'll work perfectly for what we need, and there's nothing wrong with you using the combined file in your project as well. So next thing we need to do is add a reference to the everlive.all.min.js file into our index.html file. Now for the sake of speed and focusing on what I want to accomplish in this video, I'm just going to source the file before require.js loads. But I want to point out that Everlive and its dependencies can be loaded asynchronously as dependencies to an AMD module if we want to configure it that way. And later on in the series, like I said, I plan to cover on how we can go about doing that. Then our next step is to replace our in-memory data sources. So let's open up our categories data source and paste in a completely new module definition for it. Okay, so I've replaced the code that was in this file with code that I pasted in. Now I've changed some things up a bit. Now we're returning a constructor function that takes an optional sort and filter argument. Now just inside this we have something called cat model. And this object's important because our data source will use this to configure how it should parse a remote response from backend services when we ask for category data. So in other words, it's going to help map that response to how the data should be represented in our client-side JavaScript. So as we go through this, you can see first that the ID for a category will be the ID with a capital I field that comes in our response. And here we're defining the fields that should be available on a category instance. So for example, the name property with a lowercase n is mapped to the name field with an uppercase n in the data that we got back from backend services. We've provided a default value of null. The created at property with a lowercase c is mapped to the created at field with an uppercase c that came back from backend services. And we have a default value of a new date instance. We're not using user ID for now, so we'll skip it. And finally, our isDefault property that starts with a lowercase I is mapped to the isDefault field with an uppercase I that came in from our data from backend services. The nice thing about mapping like this is it allows you to maintain the types of coding conventions that are typical in client-side JavaScript. Member variables are camel case with leading lowercase, and we don't have to give that up just because our backend services content type fields were named with capitals. Next, here's our new data source. Instead of an in-memory one, this one has a type of Everlive. And by the way, when we loaded the Everlive client library and its dependencies, it automatically added this type of data source so that Kendo UI knows what we're talking about. And next you can see that we're telling it to use the cat model that we just looked at for the schema. And then below that in the transport object, we're telling it that the type name to use is categories. Now this should match the name of the content type that we created in backend services exactly, because that's what we want to connect this data source to. And finally, the caller could pass in a custom sort to the constructor function if they want, but we're falling back to a default sort if they don't. So in our old data source, we were handling a new category/add event, and we're still doing so now. When a new category/add event occurs, we'll add it to our data source, and then we're publishing an event saying that the category's been added, which we could use down the road for notifications if we want. And then we're calling sync on our data source, which will cause our data source to communicate any changes, like the creation of this new category, to our backend services. All right, so let's open up our to-dos data source and see what its new code looks like. So I've replaced the code that was in this file with code that I pasted in. It's also returning a constructor function. We still have a local category variable that we'll use to keep track of the currently selected category. Here's our to-do model, which will act as the schema for an item in the data source. Our ID is the ID field with a capital I. Now, our fields on a model instance for to-do include title, which is mapped to title on the back end with a capital T, and we've defaulted it to null. Created at, which is mapped to the created at with a capital C field on the back end. We've defaulted that to a new date instance. We have a category property, which is mapped to the category field on our back end with a capital C, defaulted to null. And just like earlier, we're skipping user ID for now. We'll actually get to that later in the series. And then our to-dos data source itself looks similar to what we saw with the categories data source. Our type is EverLive. The schema points to the to-do model that we just looked at. The transport type name in this case is to-dos, which is what we called our content type in the backend services. We're sorting by created date in descending order. And just like our old data source, we're handling a new to-do/add event, and when one occurs, we add the to-do to our data source, and notice that we're getting the ID off of our stored category object. Then we call sync to communicate those changes to the backend. We also still handle the category/selected event like our old data source did. We just store the currently selected category locally so that we can use it when a new to-do is added above. Now we need to add a module to our app that will contain settings for client libraries that we'll be adding to the project over time, like the EverLive.js client library that we added today. So I'm going to right-click the app folder and add a settings.js module. Right now it's not much. It's an AMD module with no dependencies, and it returns an object with an EverLive property on it. This EverLive property is an object that needs an API key value, which we can get if we open up our backend services project. So remember, our left-hand menu has the option for API keys. If we click on that, we'll see the API key right here. We can copy it, and then we'll paste it here into our settings module. So now we just need to update the app module. Okay, so we've added a few things. You can see that we're passing the settings module in as a dependency now. Next, let's scroll down and look at how the app module itself has changed. Our init method is a bit different than before. So we're setting aside a reference to the module's this context because we'll need to be able to access it in some of the callbacks below. And then we're creating a new instance of our EverLive client library. This is where the settings from our settings module are being put to use. Next, we're using jQuery's when method to return a promise that wraps two other operations, load UI and get default cat. Now, once both of those operations have completed, the then method's handler that we're passing in will be invoked. Inside that handler, we're setting the default category on our app module, and then we're publishing that default category as the category/selected event. Now, we're doing this because this code is executed as the app stands up, and the user can't pick a category while it's loading. But we want a category to be active so that once the app loads, the user sees the default categories to-dos listed on the screen. Now, once that's done, then we create the instance of our Kendo UI mobile application. So let's double back and let's look at what the load UI call is doing. We've taken our earlier require call that loads our views and just wrapped it with a promise to make it easier to chain operations. You can see that once our views have loaded, here inside the require callback, we resolve the promise. The getDefaultCat method is also returning a promise. First, we check local storage to see if we have a default category there. If not, we stand up a categories data source and filter it to where isDefault is true. Then we call fetch, which causes the data source to reach out over HTTP and pull the data from Telerik Backend Services. The callback that we pass to fetch is executed once we get a response. So inside it, we're storing the default category in local storage, and then we resolve the promise, passing in the category as the value. And here below that, you can see that if we did already have a default category in local storage, we would just parse it into an object instance and resolve the promise. In that case, we wouldn't even need to make the HTTP call. The other thing to note on our app object is that since our data source modules now return constructor functions, we need to call new on them here to get our data source instances. Just a couple more tweaks and we'll be ready to run our app. So let's make some changes to our categories module. This is the backing JavaScript for our categories view. Originally, we had this behavior execute when a user selected a category. We'd get the name of the category, then we'd publish it as a category selected event, and then we'd navigate to the to-dos view, passing the category name on the URL. However, our in-memory version of categories didn't have an ID field like it does now. So now our data on this event object has both the ID and name of our category, and then we're going to store that category choice in local storage as our default category. That way, we'll actually load the last category that the user had selected the next time they open the app. Then we publish the category object, not just the name, under our category/selected event. Then we navigate to the to-dos view, but this time we're actually passing the category ID on the URL and not the name. We've also added a Kendo UI view event handler, which we'll need to wire up in a moment in our template. This is a before show handler, and it clears any filters on the categories so that each time our categories view loads, we see all of them. Now we need to add that binding to the before show method in our template. So we'll scroll over here, and I'll paste in our data-before-show attribute. And you can see that the value is app.categories.events.beforeshow, which binds it to the method we just saw here. Alright, let's tweak our to-dos view module as well. Okay, so I've replaced the code that was in this file with code that I pasted in. The main change here is in our after-show event handler. I've added this fetchMeMaybe function, and it's taking to-dos as the first argument and a callback as the second. Let's see what that function's doing real quick. So this function is keeping track of whether or not we've ever fetched data for the type passed to it, so to-dos in this case. If we haven't fetched before, we tell the data source to fetch the data from backend services, passing our callback to fetch so that it will be executed once our data has been retrieved. But if we've already fetched, we just invoke the callback that was passed to us. I'm doing this to minimize unnecessary round trips to the server. So now let's go back and look at what the callback that we passed in does. First, we make sure we have category data. So if a category ID wasn't passed on the URL, in other words, the app is starting up, then we grab the default category from our app object. If an ID was passed, we use the fetchMeMaybe function to potentially fetch categories from the server, or if they've already been fetched, which is likely, we'll just use what was returned. And then we filter the data based on the category ID we were given. Then we resolve the promise, passing the category object as our data. Now once we have our category, the callback that we passed to then will be invoked, and you can see that we're filtering the to-dos based on the category ID. And then we set the title on the navbar to the category name. Now one other thing we've changed in this module is in our remove to-do handler method. After the to-do is removed, we call sync on the data source so that these changes will be persisted to Telerik Backend Services. Great, so now we're ready to give our app a test run and see if our changes worked out like we hope. So it's loaded the default category, which is work, and we can see the to-do we entered using the Backend Services portal. I'll go ahead and add another to-do here. And let's change categories and add one under personal. And we'll add one under other. And let's also add a new category and create a to-do under it as well. Last but not least, let's check off a to-do. And now let's go to our Backend Services portal and inspect our changes from there. We'll bring up content types. You can see our school category shows in the list. And let's look at the to-dos as well. We see our new to-dos, and we can see that the one we checked off is no longer in the list. So everything worked exactly as planned. Now, like we saw earlier, we can manage our data from here, so if we deleted one of these, of course, it would no longer show in the app either. And even though we've barely started to use our app, if we look at the overview dashboard, we'll see the beginnings of our usage metrics. Now, obviously, as more time goes on and as more users are using the app, this data will become more meaningful, but I love having this kind of immediate feedback and how our backend services are being used. Now, we've accomplished what we set out to do for part 2. Our mobile to-do list is now working against our backend services data. Be sure to check out the next video in the series where we cover mobile debugging. See you soon.